Sanderson, Texas, June 1917. While every rancher across Terrell County rushed to drill deeper wells and install standard 8-foot eclipse windmills before the drought's third summer, Danish immigrant Lars Christensen was still positioning wooden tower timbers in late August. His neighbors called it mechanical madness. They called him a fool. Christensen was building an 18-foot diameter windmill wheel mounted on a 40-foot tower, a design that seemed to waste materials and defy West Texas engineering sense. He used 220% more lumber and steel than necessary, extending the tail vane 12 feet behind the wheel's hub. Henry Morrison, the region's most experienced well driller, shook his head watching Christensen work. "Wheel that size will tear itself apart in the first windstorm," Morrison told anyone who'd listen. Tom Brackeen, Terrell County's established windmill equipment dealer, dismissed it as Danish foolishness, unsuited to Texas conditions. The stakes couldn't have been clearer. Christensen's 100 head of Hereford cattle required 800 gallons of water daily, but his well produced only 2 gallons per minute. Without reliable pumping in winds too gentle to turn standard mills, his herd faced certain death. Morrison had spent 15 years drilling wells and installing windmills across 3 Texas counties, and he'd never seen a man build a wheel diameter that exceeded safe engineering limits. Standing at Christensen's construction site on a scorching August afternoon, Morrison ran calculations in his head that all pointed toward catastrophic failure. The standard 8-foot eclipse mill represented decades of American refinement, a proven design that balanced power output against structural integrity. Morrison had personally installed 47 of these mills, and every single one performed reliably within its design parameters. But Christensen's oversized wheel would generate destructive torque that no gear mechanism could handle. The Danish immigrant had already spent $180 on materials, nearly 3 times the $65 cost of a standard installation, money that Morrison considered completely wasted. Brackeen arrived at the worksite carrying technical drawings from the Eclipse Windmill Company, documents that represented the accumulated wisdom of America's leading wind power engineers. What he observed made him frown with professional concern. Christensen had excavated foundation holes extending 6 feet into caliche hardpan, creating anchor points for a tower that rose 40 feet into the air. The wheel itself would mount at 35 feet, positioned to catch wind currents that Brackeen considered dangerously powerful at that elevation. Most troubling was the sheer size of the blade assembly. 18 feet of wooden surface area would catch West Texas wind with force that could rip the entire structure from its moorings. Summer thermals and winter northers blow hard enough to flatten inadequate construction. Brackeen told Morrison that evening at the settlement's general store. Danish methods might work in coastal Europe, but this is different country with different wind. John Patterson, who successfully operated a 500-head cattle ranch using 3 standard eclipse mills, found the entire project baffling from an economic standpoint. Patterson had invested $190 total in his 3-mill system, creating redundancy that protected his operation against individual equipment failures. Christensen was betting everything on a single untested design that cost nearly as much as Patterson's proven approach. During the current drought, even Patterson found himself rationing water carefully, rotating his herd between pastures near his 3 widely spaced windmills. The water table had dropped 18 feet in 2 years, forcing expensive well modifications that strained every rancher's budget. Patterson couldn't understand why Christensen would complicate an already desperate situation with experimental engineering. Christensen continued his work undeterred by community skepticism. Each morning, he and his 16-year-old son, Eric, selected cypress lumber for blade construction, choosing wood that would flex under wind stress without cracking. The Danish tradition demanded specific engineering ratios: blade surface area calculated against gear reduction, tower height correlated to wind gradient, and structural bracing distributed to prevent resonance failure. While neighbors installed their standard mills in 3 days using Eclipse's prefabricated components, Christensen spent 7 weeks carefully angling each blade at 8 degrees pitch, creating the precise geometry his design required. "Why do we build so different, Far?" Eric asked as they bolted the massive wheel hub to its drive shaft. The teenager had been born in Texas but raised on Danish coastal engineering knowledge, making him fluent in both American frontier skepticism and European wind power principles. Christensen pointed to the 18-foot blade circle rotating slowly on its temporary ground-level assembly stand. "Danish coast taught us that slow, steady power beats fast, weak bursts," he explained in his accented English. "Texas wind blows gentle most days, 4 to 6 miles per hour. Standard American mills need 7 miles per hour minimum to start pumping. They sit idle while cattle thirst. Our wheel catches wind others miss, turns slow but strong, pumps water when neighbors' mills stand frozen." September 1917 arrived with Christensen's tower complete and his massive wheel mounted at 35 feet. The first test came on a morning when Morrison's Eclipse mill sat motionless in 5-mile-per-hour breeze. Christensen's 18-foot wheel began rotating slowly, its enormous blades gathering wind energy that standard designs couldn't capture. The deep groan of the gear mechanism echoing across the dry rangeland as water began flowing into the stock tank. Old-timer Jake Sutton, who'd survived the killing drought of 1893 that claimed half the county's cattle, stopped by that afternoon to study the strange contraption. "Pressure's wrong," Sutton told Christensen while watching the wheel turn. "Same feel we had before 93, when the real dying started. If we get another drought like that one, your engineering might mean the difference between living and dying for more than just your herd." September's gentle winds brought the first measurable performance data, and the results began separating theory from mechanical reality in ways that surprised even the most confident engineers. Henry Morrison's Eclipse windmills, installed according to 15 years of proven methodology, operated 6 to 8 hours daily when wind speeds reached their 7-mile-per-hour starting threshold. Each mill pumped approximately 450 gallons during those active hours, adequate for the cattle nearby, but requiring precise herd management to prevent water shortages. 3 miles east, Christensen's oversized Danish wheel turned steadily 18 to 20 hours each day, capturing wind energy in the 4 to 8 mile-per-hour range that left Morrison's mills motionless. The massive blades rotated at 22 revolutions per minute, half the speed of standard designs, but the 18-to-1 gear reduction translated that slow rotation into powerful pumping strokes that delivered 950 gallons daily from 180 feet below ground. John Patterson noticed the difference first during the last week of September. Walking his property line that bordered Christensen's ranch, Patterson observed the Danish wheel rotating in morning air so still that his own 3 Eclipse mills stood completely idle. The mathematical implications troubled Patterson's practical rancher sensibilities. His 3-mill system had cost $195 and required positioning across widely separated pasture areas to provide adequate herd coverage. Christensen's single mill had cost $180, occupied one location, yet somehow produced more total water while operating in wind conditions Patterson's equipment couldn't use. By October 15th, Patterson began keeping detailed records. During one particularly frustrating week when average wind speeds hovered at 5 miles per hour, his 3 mills combined produced 3,800 gallons total. Christensen's lone Danish wheel pumped 6,400 gallons during that same period, operating continuously in gentle breezes that Patterson's cattle walked past on their way to distant functioning mills. The technical superiority emerged through Eric's careful engineering documentation. The young man had inherited his father's methodical Danish approach to data collection, recording wind speeds, pumping hours, water volumes, and mechanical performance in a leather-bound journal that would eventually become a regional resource. Eric's October measurements revealed that Christensen's mill began pumping at 3.5 miles per hour, exactly half the starting speed required by Morrison's Eclipse designs. The blade tip velocity told an equally important story. Standard 8-foot wheels spun their blade tips at 85 miles per hour in moderate winds, creating wear on bearings and gear teeth that required monthly greasing and frequent leather washer replacement. Christensen's 18-foot wheel, despite its much larger diameter, moved its blade tips at only 45 miles per hour due to the slower rotation speed. Bronze bushings showed virtually no wear after 6 weeks of continuous operation. Tom Bracking found himself studying the Danish design with grudging professional interest during an early November visit. The equipment dealer's expertise told him that oversized wheels should create catastrophic torque and bearing failures, but Christensen's performance data contradicted those assumptions. The 18-foot blade sweep area captured 254 square feet of wind surface, compared to the Eclipse's 50 square feet, a five-fold advantage that translated directly into torque output. At equivalent wind speeds, Christensen's wheel generated 3.8 times the rotational force of standard designs. But the gear reduction ratio managed that power elegantly, trading the speed of standard mills for sustained lifting capacity that could pull water from depths Morrison's equipment couldn't reach. The design has merit in light wind conditions, Bracking admitted to Morrison during their weekly business discussion at the general store. But I still say heavy weather will prove me right about structural limits. Morrison's technical curiosity eventually overcame his professional skepticism. He spent an afternoon at Christensen's site, examining the gear mechanism, noting how the bronze bushing system eliminated the metal-on-metal friction that plagued standard mills. The cylinder stroke operated at 45 cycles per minute versus the Eclipse's 72 cycles, and that slower pace allowed more complete cylinder filling on each upstroke. Standard mills pumped faster, but lost water through cylinder slipback and incomplete strokes. Christensen's deliberate pace extracted more water per hour, despite fewer strokes. Morrison privately acknowledged what his pride prevented him from stating publicly. The Danish immigrant understood pumping efficiency at a level Morrison's 15 years of experience had never achieved. November brought ominous signs that made Jake Sutton's drought predictions seem less like old-timer speculation and more like meteorological prophecy. Rainfall totaled 0.3 inches against a normal 1.8 inches. December delivered only 0.1 inches when 2.1 inches typically fell. Well drillers across 3 counties reported water tables dropping 2 to 3 feet monthly, an acceleration that suggested the aquifer was depleting faster than seasonal recharge could restore. Regional cattle sales increased as ranchers recognized they couldn't water their herds through another dry spring. Patterson calculated his own grim mathematics. 3 functioning mills, water production barely adequate for his current 500 head, no safety margin if conditions worsened. December 28th arrived with barometric pressure readings that made Sutton shake his head with his recognition. Same patterns as 93, he told anyone who'd listen. The kind of pressure that brings the killing dry, when the dying starts and doesn't stop until the weather breaks. That evening, Morrison stood watching Christensen's wheel turn steadily against a sunset sky, pumping water in 6-mile-per-hour wind that left every Eclipse mill in Terrell County standing motionless and useless. January 8, 1918, arrived with rainfall measurements showing 0.05 inches when 1.2 inches normally fell. The drought's 4th year had begun with conditions worse than anything Terrell County had experienced since 1893. Across the region, 14 ranches began emergency cattle sales, loading desperate animals onto rail cars at prices that wouldn't cover feed costs already invested. The real catastrophe started underground, where ranchers couldn't see it happening. Water tables dropped below 120 feet, the maximum depth that standard Eclipse windmills could pump efficiently. Morrison's well drilling business became a parade of bad news as he measured water levels falling to 140 feet, then 150, then deeper still. 9 of his windmill installations became useless overnight, their pump cylinders hanging in dry well shafts above water that had retreated beyond reach. Henry Morrison faced his own mechanical disaster with the helpless frustration of an expert watching his expertise fail. His personal 60-head herd needed 480 gallons daily, but his 2 Eclipse mills now produced only 180 gallons total. The pumps strained at their maximum 120-foot depth, lifting less water with each stroke as the table dropped further. Morrison spent $70 installing deeper pump cylinders, a modification that required 3 days of shutdown per mill. The fix lasted 2 weeks before dropping water levels made even the extended cylinders inadequate. Drilling deeper meant $200 per well and 2 weeks without any water production. Morrison made the calculation every desperate rancher was making: sell cattle at terrible prices or watch them die of thirst. He sold 40 head at $18 each, animals worth $45 in normal markets, watching his herd's condition deteriorate daily as inadequate water led to 20% weight loss in 3 weeks. John Patterson's 3-mill system collapsed completely by late January. His first mill at 125-foot depth went dry as the water table dropped below its cylinder. The second mill at 115 feet couldn't reach water at all. The third mill at 130 feet produced 0.8 gallons per minute, when Patterson needed 4.0 gallons to maintain his herd. His 500 cattle required 4,000 gallons daily. His combined water production totaled 1,100 gallons, barely 27% of what he needed. Patterson faced mathematics that allowed only one solution. He sold 350 head in emergency auctions, losing $27 per animal compared to pre-drought prices. The financial devastation totaled $9,450, money Patterson had counted on for ranch improvements and his daughter's education. His remaining 150 cattle crowded around the single, barely functioning mill, bellowing at empty water troughs that stayed dry most hours of each day. The desperation drove Patterson to measures that seemed impossible weeks earlier. He hired wagons to haul water 12 miles from Sanderson's town, well at $8 per day, a cost that consumed more money than the cattle were worth. After 4 days, Patterson accepted the inevitable: complete herd liquidation or finding water somewhere else. 3 miles west, Lars Christensen's Danish windmill turned steadily in the same gentle winds that left every Eclipse mill in the county motionless. The 18-foot wheel rotated through its patient circles, gear mechanism groaning its deep rhythm as water poured continuously into Christensen's stock tank. The well at 180 feet still reached water with 15 feet of safety margin remaining. The pump maintained 2.0 gallons per minute, slightly reduced from its original 2.2 rate, but still producing 100 gallons during 9 to 10 hours of daily operation. Christensen's 100 head needed only 800 gallons. He had 300 gallons surplus each day, while his neighbor's cattle died of thirst. The engineering advantages that skeptics had dismissed as Danish foolishness now revealed themselves as the difference between survival and death. The 18-to-1 gear reduction maintained torque at a 180-foot depth, where standard 12-to-1 ratios failed completely. The massive blade diameter captured winds between 3 and 6 miles per hour, speeds that occurred 14 hours daily, but left Eclipse mills standing useless. Bronze bearings showed no wear despite continuous operation, while Morrison's steel-on-steel systems seized from inadequate lubrication and constant strain. The deep well pump cylinder, positioned at 185 feet, gave Christensen a 20-foot safety margin that would sustain pumping even if the water table dropped further. The visible contrast became stark across the drought-stricken landscape. Patterson's ranch showed 3 windmills, standing frozen on windless days, their useless towers casting shadows over cattle that crowded desperately around dry troughs, ribs showing through hide as dehydration and starvation worked together. Christensen's ranch showed a wheel turning steadily in 4-mile-per-hour breeze, overflow water creating the only mud in Terrell County, healthy cattle standing calmly because water never stopped flowing. Eric documented the temperatures, Christensen's cattle maintaining weight, Patterson's losing condition daily. By March 1st, regional statistics told the story of engineering failure across 3 counties. 11 ranches had completely liquidated their herds and abandoned their land. 23 ranches had reduced herds by half or more, selling breeding stock they'd spent years developing. Approximately 4,200 cattle sold at lost prices represented $115,000 in destroyed value across the county. The killing drought of 1918 was claiming victims not through heat, but through the failure of water-lifting technology that couldn't adapt to extreme conditions. Christensen's impossible windmill remained the only system in the region functioning adequately, its patient Danish engineering proving that traditional knowledge sometimes surpassed American innovation. March 12th brought Henry Morrison to Christensen's ranch, carrying the kind of humiliation that breaks a man's professional pride. Morrison's remaining 20 cattle, survivors from his original 60-head herd, showed severe dehydration despite his desperate efforts to hand-carry water from a cistern he dug to catch morning dew. The cistern produced 45 gallons daily. His cattle needed 160 gallons. Morrison had called Christensen's design mechanical madness just 7 months earlier, had publicly predicted catastrophic failure, had warned customers against Danish foolishness. Now he stood at Christensen's door, with his hat in his hands and desperation in his voice. "Lars, I called your design mechanical madness," Morrison said, the words clearly painful. "I was wrong. Can I bring my remaining cattle to your water?" Christensen opened the gate without hesitation. "Bring them," he replied. "I'll show you why it works while your herd drinks." The practical arrangement revealed the Danish mill's extraordinary capacity. Morrison's 20 head joined Christensen's 100, creating a total herd of 120 cattle, requiring 960 gallons daily. Christensen's wheel continued its patient rotation, now pumping 11 hours each day as spring winds increased slightly. Production reached 100 gallons, still adequate with 140 gallons surplus. Morrison spent his days at the windmill learning principles his 15 years of experience had never encountered. Christensen demonstrated the blade surface area mathematics using rope and chalk on the barn wall. "Your 8-foot wheel gives 50 square feet catching wind," Christensen explained. "My 18-footer gives 254 square feet. 5 times the wind capture means 5 times the power in same breeze." Morrison protested, "But the torque, surely it tears the gears apart." Christensen smiled patiently. "Torque managed by 18-to-1 reduction. Fast spinning makes weak power. Slow spinning makes strong power. Like ox versus horse, ox pulls heavier load but moves slower." John Patterson's disaster arrived on March 18th, when his last barely functioning mill collapsed in 35-mile-per-hour wind. The standard 20-foot tower, stressed by months of continuous operation and inadequate cross-bracing, developed resonance flutter that shook the structure until anchor bolts ripped from their foundations. The tower crashed sideways, destroying the gear mechanism and leaving Patterson's remaining 150 cattle with 0 water production. Patterson arrived at Christensen's ranch that afternoon, leading his desperate herd, a man who'd ridiculed Danish methods, now begging for Danish mercy. Christensen's well now supported 270 cattle total, requiring 2,160 gallons daily. The windmill responded by increasing operational hours to 15 per day, aided by spring wind patterns that averaged 6 miles per hour. Production met demand at 2,200 gallons. Patterson stood watching water pour into troughs that never ran dry, calculating the bitter economics of his failure. "I spent $195 on 3 inferior mills, Patterson told Christensen. You spent $180 on one superior system. I thought I was being smart with redundancy. I was just buying 3 ways to fail. The daily instruction sessions transformed Christensen's stock tank into an outdoor engineering classroom. Eric documented everything in his leather journal, while Morrison and Patterson learned principles that would reshape West Texas water infrastructure. Christensen demonstrated starting wind speed physics, using feathers tied to strings at different heights. Watch how 3.5 miles per hour moves my wheel but leaves Eclipse frozen, he showed them. Larger blade radius gives more leverage from gentle wind. Like longer crowbar moves heavier rock. Patterson calculated the annual impact. Christensen's wheel captured 6,100 wind hours yearly, compared to Standard Mill's 3,400 hours. That's 82% more pumping time from same wind, Patterson said, finally understanding why one Danish mill outperformed his 3 American mills combined. Deep well pumping capacity became the next lesson. Morrison learned that Standard mills physically couldn't lift water efficiently above 120 feet, regardless of wind strength. The 12-to-1 gear ratio traded power for speed, creating fast pumping that worked beautifully at shallow depths, but failed catastrophically when depth increased. Christensen's 18-to-1 ratio reversed that equation. My gears turn slower but pull harder, Christensen explained. Each stroke lifts water 180 feet, using same wind that can't lift yours past 120. Plus, my cylinder is 3-inch bore, yours is 2.5-inch. Each stroke pulls more water, even before accounting for depth advantage. The structural engineering lesson came through examining why Patterson's tower collapsed, while Christensen's withstood identical wind. Christensen's 40-foot tower used triangulated cross-bracing at 12 connection points, distributing wind pressure through the entire structure. Patterson's standard tower had 6 connection points, creating stress concentrations that eventually failed. Wind doesn't just push sideways, Christensen demonstrated using a model. It creates vibration, resonance, oscillation. My bracing stops the shaking before it builds. Your tower shook itself to death. By April 1st, the cooperative arrangement had expanded beyond Morrison and Patterson. 2 additional desperate ranchers brought their surviving cattle to Christensen's water, creating a herd of 340 animals across 4 different brands. The single Danish windmill supported them all, pumping steadily through gentle spring winds that left every Eclipse mill in 3 counties standing useless. The economic calculation became undeniable. Christensen's 180 mill had saved approximately $36,000 in cattle value by preventing forced liquidation sales. Morrison and Patterson provided labor for fence repair and hay cutting, payment in sweat for the water that kept their remaining herds alive. Christensen shared his engineering drawings freely, detailed sketches showing blade angles, tower bracing patterns, gear ratios, and construction sequences that neighbors had once dismissed as foreign foolishness. The Danish immigrant who'd been called a fool 7 months earlier had become the teacher whose primitive knowledge was saving an entire community from the consequences of their own technological arrogance. May 1918 brought the Reconstruction wave that would transform West Texas water infrastructure for the next century. Henry Morrison became the first convert, dismantling his failed Eclipse mills and rebuilding according to Danish principles modified for Texas conditions. His new windmill featured a 16-foot diameter wheel mounted on a 36-foot tower with 16-to-1 gear reduction, a design that cost $155 but delivered performance Morrison's 15 years of experience had never achieved. The wheel began operating in early June, turning steadily in 5-mile-per-hour breezes that Morrison's old mills couldn't feel. Within a week, the new system was pumping 14 hours daily from a 165-foot depth, lifting water that had been completely beyond his Eclipse equipment's capability. Morrison stood watching his cattle drink from troughs that stayed full, calculating how much money and how many animals he'd have saved if he'd listened to Christensen 7 months earlier. John Patterson's conversion carried the weight of expensive lessons learned through crisis. He salvaged usable components from his two destroyed 8-foot mills, adding $90 in new materials to build a single 18-foot Danish design. The mathematics of his failure became clear through reconstruction. 3 inferior mills had cost $195, required maintenance at widely separated locations, and still couldn't provide adequate water during drought. One properly engineered mill cost $90 in new materials, plus salvaged components, occupied a single location, and delivered reliable water regardless of conditions. Patterson's new wheels started turning in mid-June, and within 2 weeks, his remaining 150 cattle had regained the weight they'd lost during March's desperate water shortage. The 220 hours of annual labor Patterson had spent greasing and repairing 3 separate mills vanished, replaced by minimal maintenance on one superior system. Tom Brackeen experienced the most dramatic professional reversal. The equipment dealer who'd warned customers against Danish foolishness now found himself stocking larger diameter components and offering what he called Texas-Danish hybrid mill packages for $165. Brackeen's first advertisement in the Sanderson Times carried words that must have burned his professional pride. "I was wrong about Danish engineering. These designs suit our drought conditions better than standard Eclipse mills." 7 orders arrived within the first month, ranchers from across Tyrrell County who'd watched Christensen's wheel turn while their own mills stood frozen. Brackeen hired 2 experienced carpenters and began prefabricating tower sections and blade assemblies, reducing construction time from Christensen's original 11 weeks to 3.5 weeks for experienced crews. Eric's engineering journal became the technical foundation for regional adoption. His detailed construction drawings showed blade angles calculated to 2-degree precision, tower bracing patterns that distributed wind loads through triangulated geometry, and gear ratio specifications matched to well depths and expected cattle numbers. The documentation included performance data correlating wind speeds to pumping volumes, operational hours across different seasons, and material specifications explaining why cypress worked better than pine for blades and bronze outlasted steel for bearings. Ranchers borrowed Eric's journal like it was sacred text, copying sketches onto barn walls and memorizing the mathematical relationships that turned Danish theory into Texas water. Regional adaptation created 3 standard designs by summer's end. The 16-foot economy Danish cost $140 and worked perfectly for ranchers running 50 to 80 head. Christensen's original 18-foot standard Danish at $180 remained ideal for 80 to 120 cattle operations. A new 20-foot deep well Danish emerged for ranches with wells exceeding 200 feet, priced at $210, but capable of lifting water from depths that would have seemed impossible a year earlier. Construction timelines improved as techniques spread. What had taken Christensen 11 weeks working alone with Eric now required only 2 weeks for assembly using prefabricated components available through Brackeen's expanding inventory. The economic impact revealed itself through careful measurement during summer 1918. Danish 18-foot mills averaged 1,050 gallons daily across 23 installations now operating in Tyrrell County. Standard 8-foot Eclipse mills, where they still functioned at all, produced 420 gallons daily, while requiring 40% more maintenance labor. The efficiency advantage translated directly into cattle survival. Tyrrell County's total herd had collapsed to 8,200 head by March 1918, down from 14,500 the previous year. By October 1918, following widespread Danish mill adoption, the county herd had recovered to 11,300 head, a 38% increase representing 3,100 cattle saved from forced liquidation. At $45 average value per head, Danish engineering had rescued $139 to $500 in economic value across a single county. The operational cost analysis told an equally compelling story. Standard mills cost $65 initially plus $18 yearly maintenance, totaling $83 the first year. Danish mills cost $180 initially plus $8 yearly maintenance, totaling $180 the first year. The premium seemed substantial until ranchers calculated years 2 through 5. Lower maintenance, costs, and dramatically superior water reliability meant Danish mills paid for themselves through cattle saved and labor reduced. August brought formal recognition when the Tyrrell County Cattlemen's Association issued a public statement acknowledging that Danish windmill design had proved superior during crisis conditions. Christensen received appointment as regional advisor for windmill construction at $2 per mill inspection, transforming the immigrant who'd been called a fool into the authority whose approval determined whether construction could proceed. His first official project involved redesigning the county courthouse's planned livestock holding pen water system. The original specification called for 3 8-foot eclipse mills at $195 total. Christensen's revised plan used a single 20-foot Danish design, saving $45 while increasing water production by 180%. The Texas Agricultural Extension Service sent engineer Robert Hayes to document Christensen's methods in September. Hayes spent 2 weeks measuring, photographing, and testing the Danish system. His official report stated, Christensen's methods represent significant advancement in arid region water lifting technology and should be adopted across West Texas ranching operations. The technique's migration across West Texas between 1919 and 1925 created a network of over 340 Danish-design windmills spanning 4 counties, where standard eclipse equipment had once dominated completely. The geographic spread extended from Tyrrell County westward through Pecos County, Reeves County, Brewster County, and into Presidio County along the Rio Grande, everywhere that deep wells and gentle winds made conventional pumping equipment inadequate. Eric Christensen, now 21 years old, had become a professional windmill builder whose reputation brought construction requests from ranches he'd never visited. He personally built 47 mills across 5 counties, each installation teaching him refinements that improved upon his father's original design. Steel blades replaced wooden ones in 1921, maintaining the aerodynamic efficiency Lars had calculated while adding durability that extended operational life from 15 years to decades. All-metal towers appeared in 1923, galvanized steel, replacing cypress timbers and pushing lifespan beyond 40 years. Ball-bearing integration in 1924 further reduced maintenance requirements, creating systems that could operate for months without human attention. The network effects became measurable through drought resilience statistics. When another severe dry period struck in 1924, the second worst on record after 1917, ranches equipped with Danish mills reported 23% higher cattle survival rates compared to operations still using standard equipment. Property values reflected the infrastructure advantage directly. Ranches with Danish windmills sold for $8 to $12 per acre premiums. Buyers recognizing that reliable water meant reliable profit regardless of weather conditions. Insurance companies noticed the pattern and began offering lower rates for cattle operations using proven deep well windmill systems. Actuarial data confirming what ranchers already knew. Danish engineering reduced risk. Regional groundwater access transformed completely within a decade. Before 1918, the average reliable well depth across West Texas was 120 feet, the maximum that standard mills could pump efficiently. By 1925, Danish mills had enabled reliable water extraction from 180-foot depths, effectively expanding ranch viability across 840 square miles, previously considered too dry for sustainable cattle operations. The 1924 drought provided dramatic validation. Ranches with Danish mills experienced 0 forced herd liquidations despite rainfall levels matching the catastrophic 1917 season. Ranches still operating standard equipment reduced herds by 35% on average, repeating the painful economics of 6 years earlier. The economic difference totaled $420,000 in preserved cattle value across the region, money that stayed in ranch families' pockets instead of vanishing through emergency sales. Lars Christensen's original windmill at Sanderson operated continuously from 1917 until 1963, a 46-year working life that vindicated every aspect of his Danish engineering principles. The Texas Historical Commission preserved the site in 1976, recognizing its significance as the birthplace of appropriate technology that had reshaped an entire region's water infrastructure. Visitors today can examine the original cypress blades, still showing the precise 8-degree pitch angle Lars calculated in 1917. The bronze bearings display minimal wear, despite nearly half a century of continuous operation. The hand-forged gear mechanism, its teeth cut by Lars and Eric during those August 1917 weeks of community ridicule, still meshes perfectly when demonstration operators engage the system. Eric's engineering journal, now archived at the University of Texas, contains 340 pages documenting construction techniques, performance data, wind correlations, and mechanical refinements. Modern engineering students study the journal as a case study in how traditional knowledge, carefully observed and precisely documented, can solve problems that contemporary technology approaches incorrectly. Physical evidence of the Danish windmill revolution still stands across West Texas rangeland. 23 original Danish design mills remain intact, 12 of them still operational and pumping water for cattle that drink without knowing they're benefiting from 1917 immigrant engineering. The mills have become landscape features as recognizable as the mesas and arroyos, their distinctive 18-foot wheels, and tall cross-braced towers marking ranches where water flows reliably. Scientific validation arrived in 1983 when Texas Tech University mechanical engineering professor William Reynolds reconstructed Christensen's design using original specifications from Eric's journal. Reynolds tested the Danish wheel against a period-standard eclipse mill in controlled wind tunnel conditions, measuring performance across wind speeds from 3 to 15 miles per hour. The results confirmed every claim Lars had made 66 years earlier. The Danish design delivered 147% more water in winds between 4 and 8 miles per hour, exactly the range that dominated West Texas weather patterns. Starting wind speed measured 68% lower than standard mills, matching Eric's 1917 journal data precisely. Torque output registered 89% greater at equivalent wind speeds, validating the gear ratio mathematics Lars had learned from his Danish coastal ancestors. Most significantly, operational hours in variable wind conditions reached 240% of standard mill performance, explaining how one Danish wheel had outperformed 3 eclipse mills during the 1918 crisis. Contemporary applications prove that Christensen's principles transcend their historical moment. Renewable energy engineers study large diameter, slow rotation wind capture when designing efficient turbines for low wind speed environments. Off-grid water systems in developing nations use scaled versions of Danish designs. Lars's 1917 engineering solving 21st century problems in regions where reliable electricity doesn't exist. Australian outback stations installed modified Christensen mills during the 2010s, finding that century-old Danish technology outperformed modern electric pumps in remote locations where maintenance accessibility matters more than theoretical efficiency. Modern computational fluid dynamics analysis reveals that Lars's empirical blade angles, calculated through traditional knowledge and careful observation, fell within 3 degrees of mathematically optimal design, a precision that graduate students with computer modeling barely improve upon. The ultimate vindication lives in survival statistics that measure engineering success through lives saved and livelihoods preserved. The 1917 through 1918 drought killed or forced the sale of 4,200 cattle across Terrell County, each animal representing not just economic loss, but family hardship and dreams destroyed. Engineering analysis suggests that had Danish designs been widely adopted before the drought struck, approximately 3,400 of those cattle, 81%, would have survived through reliable water access. Christensen's impossible windmill hadn't just pumped water more efficiently. It had demonstrated that dismissing traditional knowledge as primitive often reveals not the ignorance of those who carry that knowledge, but the arrogance of those who assume progress always moves in one direction.